Stop worrying about homework and start learning with confidence. This is Ask Learn. Complete help for every subject. Like, share, subscribe for daily learning videos.
So in this problem, we are asked to explain why the atomic radius of row 3 transition metal elements are same as the row 2 elements. So uh, what is an atomic radius? We know that atomic radius is simply the distance of the nucleus of an atom from the boundary of the outermost shell of electrons in an atom. So in this case, if this is the outermost boundary of the shell of electrons, so the atomic radius here is just the distance from the nucleus to the boundary of the outermost shell. Now, when we go down in a periodic table, or we have an increasing number of rows, we are simply adding more shell of electrons surrounding the nucleus. That means that um, the outermost shell is going far away from the nucleus, and that's why the atomic radius is increasing with the increased number of rows. So again, if we have another row, we have another shell of electrons, and which is more far from the nucleus, and that's why it should have a larger value of atomic radius. But in case of the transition metals, when we go from row 2 to row 3, we don't see very much change in the atomic radius, or the row 3 transition metal elements atomic radius is almost similar to the row 2 elements atomic radius. So the reason is, let's look at these two elements here. This is cadmium, which is from the uh, row 2 elements of transition metals, and this is hafnium for the row 3 of the transition metal elements. So in case of cadmium, if you look at its outermost shell electronic configuration, you can see that it has 4d10 and 5s2 and no electron in the 4f orbital. And in case of hafnium, just look at the change. So from here to here, we are adding 32 more electrons, but all of them are actually going either in 4f or 5p 5d subshells. Only two electrons are adding in a new shell of electrons. So the point here is that when we are going from a row 2 transition metals to row 3 transition metals, we are merely adding any new shell, or we are adding only two electrons in the new shell, but most of the electrons are still going in a lower subshell of electrons. That's why the control of the nucleus over a row 3 atom is almost same as the control of the nucleus over a row 2 element. That's why in case of the transition metals from row 2 to row 3, the atomic radii remains almost unchanged.